So if we want to find the equation of the line, we just need to figure out the slope or the multiplier and the y-intercept, which is a constant value. If we can figure out those two parts, we can write the equation in graphing form. So when we're given 2 points, I can always just kind of sketch a little graph, 3 over 5 up, maybe somewhere around here, 9 over 13 up, right? I've kind of got a picture like that. Really, all I need to figure out is slope first. That's kind of the main thing. So I'm going to start with that. From these two coordinates, 5 and 13, I can get a rise of 13 minus 5, which is plus 8. And from the x coordinates, okay, I can get my run. So 9 minus 3 gives me plus 6. And when I find my slope then is, slope works out to be positive 8 over positive 6, okay, which simplifies down to, okay, so that's plus 6, and that simplifies to 4 over 3. Okay, so I end up with a 4 over 3 slope. So I've already got the m part of this equation. Okay, I can use a slope formula to work out the slope, the change in the y over the change in the x, and make sure you get that in the right order. The y's are on top. Okay, it's a little bit confusing sometimes because the x's come first, but the y's are on top. So we've got our slope, and I just have to figure out the y-intercept now. So what I could do is I could potentially use my slope to go backwards all the way to 0. Okay, so if I had a table of values, and we had done this in a table of values before, okay, so if I had a table of values here, which I'm going to do off to the side, and again, you don't necessarily need to do this, but I'm at 3, 5, and I know that if I go backwards 3 minus 3 to 0, I can use my slope ratio minus 4 to get to the y-intercept of 1. So I can get my y-intercept that way. I can kind of track back on my graph, and it looks about the right spot. But I'm going to show you how we can do it in the equation. Okay, so I have so far calculated the slope. So I have y equals 4 over 3x plus b. And I want to solve for b. Now, one thing about equations that in a relationship, all points must be able to fit into the x and y of the equation. Okay, these coordinates have to be able to be substituted into y and x, and that's always a truth. Now, sometimes it doesn't do anything, but sometimes it does. And in this case, if I plug in one of these pairs, so I'm just going to take the first pair, 5 and 3. So if I substitute y is 5, x is 3, I can actually solve for the y-intercept b, because that's the only variable left in the equation. So solving for b then, I end up with 5 is equal to 4 plus b. Notice that that ratio of 4 is going to show up here because I've multiplied it by the 3 here. So change is 3. Going back to the y-intercept, so my change should be 4. So I do 5 minus 4, which is 1. And my y-intercept b is equal to 1. And that's what I expected when I did it in my table as well. So now I've come up with the equation of the line. Y equals 4 over 3x plus 1. Okay, so my b is equal to 1. Okay, so there it is. I've got the equation of my line, and how I did it was I calculated the slope first, and I plugged in, I set up my equation, I substituted for x and y, and solved for b. Okay, so that's what I've done, and we could do it other ways. We can use a table to get there. We can maybe count on the graph. But this is a much more algebraic way of doing it, and it starts becoming much more useful to us because we want to be able to have some sort of calculation to be able to get that b value. Okay, so let's try another one here. So I have -7, +1 is one coordinate. 3 over -5 is another coordinate. It looks like that. Maybe a y-intercept somewhere around, I don't know, maybe -3 or something. Okay, so I wanted to get my slope first. I have my y coordinates, so my change in y is going to be -5 minus 1. So I started at -5, I ended up -1. My change in y is equal to -6. The change in x, when I come across, my change in x is going to be, I ended up at 3, I started at -7, so my change in x is +10. So my slope ratio then, the slope, or my m value, is equal to -6, remember to put the y's on top, over +10, which simplifies to -3/5. Okay, so that's the first part. I want to work out the slope from the coordinates. I can draw my slope triangle to do that. I get y equals mx plus b. I can solve for that b value by substituting in for x and y. Now, does it matter which pair I use? No, because both pairs must be able to be plugged back into the equation. Okay, so I've plugged in my x and y. Okay, I'm going to solve for my b by isolating that b. So here I'm going to get -9 over 5 plus b. So I get b equals, this is going to be -25 over 5. And it's going to be, I'm going to add 9 over 5 to both sides. So I end up with b equals -16 over 5, which is about -3.2. We guessed -3. That's pretty close. Okay, so y equals -3 over 5. The slope looks about right. It's going down. Minus 16 over 5 is the y-intercept. Okay, so there it is. So we find to work out the slope, plug in our x and y, we can work out our equation that way. Okay, so here we have a custom car business. They're making, they customize cars and they make profit. So that what's being connected are the number of cars that are customized, that's the independent, and the dependent variable is the amount of profit. So I want to work out my change in y. My change in profit is going to be 70,600 minus 45,800. So that's going to be, what's that going to be? $24,800 it looks like. Okay, so 70,000, just double checking my work here. It's going to be 69, 64, 24, yeah. Okay, so that's going to be positive. So they increase their profits by positive $24,800, and that's when they make the change in the x is going to be 13 minus 9, or 4 cars. So the slope is going to be 24,800 for every 4 cars. And we can write that as a unit rate. Okay, so 24,800 divided by 4 is $6,200 for 1 car. Okay, and remember that although it's a unit rate, slope is always comparing two things. So there's my slope. So what's the profit that they make per car? That's going to be $6,200 per car. Okay, so then I need to write the equation of this. So y equals the slope 6,200 x plus b. So I still have to figure out my y-intercept. So I can go backwards in groups of 4 cars, but it's kind of hard. I can go backwards 6,200 for every car, and that would work. But again, we can always plug in x and y. So I'm going to plug in the y. The profit is 45,800 when they make 9 cars. Okay, plus b. Okay, so then I can actually just solve for b. So I'm going to end up with 9 times 6,200. Okay, so that's 55,800. So I end up with 45,800 equals 55,800 plus b. So the profit ends up being negative $10,000 for 0 cars. And that kind of makes sense because we're going to have a loss at the beginning because you have to pay for shop costs, all that kind of stuff before you can start your business, before you can start making profit. So the equation is going to be the profit is going to be equal to $6,200 per car and we're going to start off with a loss of $10,000, so minus 10,000. So there's the equation of my line. Okay, what does the y-intercept represent? It's the starting point. Or in this case, this is a loss at the beginning. Okay, so we losing money at the beginning, but as we start customizing some cars, this person is going to start making a profit.